Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, my friends and I will give a brief explanation about nozzle. The reason why we choose nozzle is because nozzle is a simple device that have many applications and can be found easily in systems around us that we use every day. So, what is nozzle? Nozzle are pipe or tube that are used to modify or change the flow of liquid or gas that pass through by varying its cross-section. It is used to control the rate of flow, speed, or the pressure of gas or liquid that pass through it. In other words, nozzle is a device that increases the velocity of a fluid at the expense of pressure. Some of the examples of system consist of nozzle devices are garden hose and fuel pump. The diagram shows a nozzle. As we can see, a nozzle inlet is bigger in cross-section than the nozzle outlet. The mass equation for nozzle is M1 equal to M2, or rho 1 times A1 times V1 equals to rho 2 times A2 times V2. The energy balance equation is Q minus W equal to M1 times theta 1 minus M2 times theta 2, or H plus V square over 2 at inlet equal to H plus V square over 2 at the exit.
How nozzle works on a system. In this part, I will choose fuel nozzles as an example. Automatic fuel nozzles are commonly used in petrol station company. It's very useful, which allow users to leave the nozzles, and once the tank is full, the fuel flow can be automatically cut off. For the operating system, there is 8 operating steps in fuel nozzle. First, users squeeze the lever and open the main poppet valve and clip it. Second, gasoline starts flowing through the system. Third, delving tip stem is forced to open. Fourth, low pressure area is created. Fifth, the nozzle starts sucking the air in through stream shaper. 6. Continuous air pressure is flow together with gasoline in alternating times. 7. When tanks are about to full, the sensing area is activated. And the last step, lost motion latch pin is ready to shut off the nozzle by closing the main poppet valve.
Assalamualaikum warahmatullahi wabarakatuh. Today, I want to talk about first law of thermodynamic for a nozzle. First law of thermodynamic say that mass is like an energy that cannot be created or destroyed, and a nozzle is a device that increases the velocity of the fluid because the cross-sectional area of a nozzle is decreased. Mass with the control volume does not change due to the high velocity of the flow, so time is not changed. Thus, volume, mass, and energy of control volume remain constant. As a result, boundary work is 0. Also, total mass into the control volume must equal to the mass leaving control volume. No properties change at the boundary of control volume with time. The mass flow rate must remain constant. This is what we call a steady flow process. General steady flow can be expressed as M1 equal to M2 or ρ1 area 1 v velocity 1 equal to ρ2 a2 velocity 2. Area inlet bigger than area outlet. Velocity inlet smaller than v outlet. Pressure inlet smaller than pressure outlet. Q equal to kosong because no time for the heat transfer due to the high velocity. Second law of thermodynamic for a nozzle. Nozzle with a flow system are optimized by their wall shape that give change in cross section. If the flow gradually compress or area decrease and they gradually expand or area increase, the flow condition are restored. It is what we call reversible process. According to the second law of thermodynamic, if there is reversible and adiabatic flow, constant value of entropy is maintained. The flow of steam through nozzle is assumed to be isentropic when the change in flow variable is more gradual. Isentropic flow occurs. Nozzle efficient equal to actually enthalpy drop per isentropic enthalpy drop.
Hello. Okay, today we will continue to discuss about simple calculation that related to nozzle. Firstly, this is a diagram that shows calculation that related to nozzle. We have pressure, temperature, velocity and area. First of all, we will learn about how to calculate mass flow rate. Firstly, we need to find specific volume of air first. This is determined from ideal gas relation in inlet condition. Okay, specific volume at inlet, we use this equation which is V1 equal to RT1 over P1. R stands for gas constant of air, which is 0.287. T1 equal to initial temperature and P1 is equal to initial pressure. After we all obtain the specific volume at inlet value, we put into the mass flow rate equation, which is M equal to 1 over V1 multiplied with A1 V1. A1 stands for initial area of nozzle, while V1 stands for initial velocity. Okay, since the flow is steady, mass flow rate through entire nozzle remain constant at this field. Secondly, we will talk about temperature. Okay, nozzle normally involve no shaft or electrical work, so W equal to 0. Secondly, negligible heat transfer, which is Q equal to 0. And small elevation change between inlet and exit, which is potential energy, is equal to 0 also. Okay. Conservation of energy relation on unit mass basic for this single stream steady flow system reduced to this formula, which is Q minus W equal to change of H, which is height, change plus change of kinetic energy plus change of potential energy. So we will obtain formula 0 equal to C multiplied with in bracket T2 minus T1 plus V2 minus V21 over 2. After all, we use specific heat at different temperature at 450K. We use table A2 to obtain CP, CV that will flow to R obtained. Okay, R will obtain with CP minus CV, which is 1 0.020 minus 0.733, that we obtain 0.287 kilojoule kg multiplied with K. V2, okay, this is formula. T2 equal to T1 minus V2 2 minus V1 2 over 2C. Okay, V stands for velocity. So we will obtain the temperature, which is 184.6 degrees Celsius. Temperature drop of air is mainly due to conversion of internal energy to kinetic energy. Next we will talk about volume. Okay, this is diagram. We have pressure, we have temperature, we have Q stand for heat loss through the wall of nozzle. WF is heat use, WH is heat supply. Conservation of energy ratio in the rate form for this single stream steady flow system. Q stands for heat loss through wall, W stands for heat supply minus heat consumed, equal to M in bracket change of height, change of kinetic energy plus change of potential energy. So this is formula. Assumption: fixed elevation, that is energy reachable, potential energy. So change of potential energy is 0. Second, change in kinetic energy is small, so we didn't count it. So we assume that change of kinetic energy also equal to 0. So inlet and exit section exposed to atmosphere, that is P1 equal to P2. Therefore, reduced form of energy equation, so we use this equation: Q minus W equal to M in bracket H2 minus H1 equal MC in bracket T2 minus T1. So we obtain the M. Okay, note. Okay, next question we will talk about is specific heat are calculated at average temperature at 300 Kelvin. We also refer table A2. Now we using this equation, PV equal to RT. So with this equation we will obtain the specific volume of inlet. So V1 equal to RT1 over V1. That's the equation that we will use. After we obtain the value, next using max conservation equation, which is mass flow rate. Mass flow rate is M equal to rho multiplied with V multiplied with A. So afterward we learn that V1 multiplied with A1 is equal to V1 VB is VB is equal to volume flow rate of inlet. So to use that, we obtain the 0.4033 m cube second. And lastly, we will talk about pressure. This is a diagram. We have temperature, we have velocity, and we have area. So based on the information given, determine the initial pressure of a nozzle system. Because specific volume, which we already learned about specific volume just now. So we use that formula. V equal to RT over P. So we change it, so we can obtain the P. So the equation for pressure is P equal to RT over V. So we obtain the pressure. That's all from me. Thank you.
The things that I learned while making this video are: I learned how nozzles work. Nozzle use pressure to increase the velocity of fluid that's flowing inside it. Other than that, I also learned how nozzles relate to the first and the second law of thermodynamic. I also learned some basic calculation that I'm sure will be very helpful if I'm answering questions about nozzle.
What I have learned through this assignment is that I can clearly state about nozzle work principle. The whole operation step of a fuel nozzle can also be described. The nozzle body is actually a system in order to put out the fuel continuously with the presence of air pressure.
Apa yang saya dapat dalam penghasilan video ni adalah saya dapat mengetahui bagaimana sesebuah nozzle itu berfungsi, konsep-konsep yang terlibat seperti konsep first law of thermodynamic iaitu steady flow process, untuk second law of thermodynamic reversible process, dan rumus-rumus yang terlibat.
Okay, Assalamualaikum. The things that I learned after making this video with my friend is be able to discuss more deeply about nozzle. Okay, nozzle is a device which accelerates fluid during the flow process. Velocity of fluid increase with decreasing pressure. Okay, after we all making this video, the things that I learned is about teamwork. Okay, we all working together as a team to obtain great answer and majority opinion about something that we didn't know. So that's all matter to me, because without teamwork, our video never done with this work. Thank you. That's all from me.
There are many things that I had learned from producing this video. First, I had refined my understanding on this chapter through discussion and explanation with my group members. Second, I have learned how to plan and manage time so that this project finish at the given time. Finally, I have developed stronger communication with my other group members and my soft skill in such as Microsoft PowerPoint.
What I have learned from producing this video is I learned how the nozzle work in system, and I can relate the nozzle with first law and second law of thermodynamic. I can also know the basic calculation in nozzle such as mass flow rate, pressure, temperature, and velocity.